Kinetic is a blockchain crypto investment firm based in Hong Kong and Puerto Rico. Founded in 2016, they were the first fund in Hong Kong and one of the earliest in Asia. With a portfolio of over 220 companies, they were seed investors in such projects as Ethereum, Parity and Polkadot, Solana, FTX and of course Handshake and Namebase. Founder Johan Chu is an active investor and supporter of the Handshake ecosystem. Over 100,000 domains, co-founder of DWeb Foundation, co-founder of HandyCon, and sponsor of the Handshake House at Miami Hack Week 2022.
All right, and we are back with Zipkin again. Here we're going to talk about this website race that we got going on. Zipkin DM'd me a little while ago saying we need more content on Handshake sites, and I said, absolutely, I agree. Let's make this happen. So we set up bounties, we set up prizes. So if you build websites on Handshake domain names, you can get some Handshake if you build something cool. I'm going to drop the Handshake website race Discord as well as this tweet. If you guys could retweet it, like it, or anything, share it around so more people are aware of this. We also partnered with Skynet and Akash. So they're giving out some Akash and Sia coin with their bounties. But I'm not going to take up too much of Matt's time. I'm going to let him take it away and talk about the more technical side of the Handshake website race.
All right, thanks. Yeah, so we want websites on Handshake. A lot of people are building cool stuff and weird things like NFTs and stuff on Handshake and applications and stuff. But we've got these cool new browsing tools now, Fingertip and Beacon Browser, and I want URLs to type into those that aren't just my own or like the couple that I know about. So this is what I want is content on Handshake, and specifically like content you can't get anywhere else, because that adds value to the network, makes the price of the coin go up, makes people need to install Handshake software on their computer so they can access this content. I've even tweeted informally that there will be extra bounties for censorship resistant related content that is generally censored, let's say. Just no hate, of course, but there's lots of loving and freedom fighting content that is also censored. Anyway, that's beside the point. We want websites on Handshake, and specifically we want secure websites on Handshake. So today we're going to talk about Dane. I'm going to spend this next half hour talking about how to set up a secure website on Handshake. And the original idea was to maybe do like a live demo, and like I was going to get a DigitalOcean server and like show everybody how to do it. Instead, I'm going to kind of do all the commands in slides. And then maybe next week I'll post a YouTube video of an actual demonstration, because so much can go wrong live. But this talk is going to be very technical. I'm talking, I was going to make it broad, and I'm going to skip the first maybe 10 slides I made. I'm going to skip the general stuff and go right to you, the web developer. You are the person who makes a website. You've made websites before. You want to make a website for the Handshake website race. Maybe you've never made a Handshake website before, or you've never made a secure Handshake website before. This talk is for you. So let's go. I was going to kind of generally talk about delegation and how, like, if I have a parking, how do I pay this parking ticket? The only thing I know is that Joe Biden is a president. Well, then you ask the Biden, he says, go talk to, I made a mistake on it. Oh yeah. He says, go talk to Gavin Newsom in Sacramento, who says, go talk to London Breed in San Francisco, who says, go talk to Doris on the 4th floor, and she'll take your payment. So this idea of delegation. And on the internet, how we delegate things is with an IP address and a public key. Basically, the IP address is where the next person is, and the public key is how it's them when you get there. Skipping this for now. Here we go. Dane. All right. Hopefully we're going to talk about it a lot this week. I think we talked about it last year, and it's one of my favorite topics and one of the most important technical topics when it comes to Handshake. And this slide is it. So this is the delegation of authority from the blockchain, from the miners, from the energy being wasted on proof of work to your website. And it's just a single flow from left to right. Proof of work secures the website. And there are 3 things you need to do if you want a secure website on Handshake. The one on the right is the web server, and that's the one that you, as I've already addressed, are familiar with. You've set up an Nginx web server or Apache. You've got a certificate from Let's Encrypt. You basically know how to put HTML files in a folder, and so that when somebody types in a URL, they see your website with security, because Let's Encrypt is easy to do. What you might not know how to do is how to set up a name server. And the good news is that name servers are almost exactly like web servers. If you have experience with Nginx or Apache, you can run NSD or bind or named or power DNS. Name servers work basically the same way. There's a config file where you plug in some options, and you got to know a little bit of that syntax. And then there's another directory where you put the content files. Instead of HTML files with websites, it's zone files with DNS records. So if you can run a web server, you can run a name server. Don't panic. You can do it. And then the third thing is the root zone, which in our case is the blockchain. And I'm hoping that the attendees of this event are somewhat familiar with Namebase or Bob Wallet or HSD. I'm going to teach you all the commands you need to do to make this grid happen. I'm going to continue to leave this slide up and go through everything here, because this is the overview. This is how it all works. So let's go left to right. And then how we're actually going to do this in practice is from right to left, but we're going to talk about authority. So left is HSD, the root zone, proof of work, mining, electricity, handshake root protocol. What do we put there? There's basically 3 record types that you're going to put in the root zone for your top level domain: an NS record, an A record, and a DS record. The A record technically is glue. More on that later. So I put the Shruggy Man next to the NS record and the A record. And that's because in the parent domain, in the root zone, NS records and the glue records are not authoritative. These records are hearsay. They are rumors, gossip. They are suggestions to the recursive resolver on what to do next. They're not authoritative. And I know I've made this mistake a lot before when I was still learning about DNS. And I'm seeing other developers make this mistake now as they learn about things about like how HIP5 works and trying to do tricky things with DNS. But the actual NS record for your name server goes in your own zone, which is a little self-referential. I've even talked to some DNS experts about this very thing recently. And there's a bit of hand waving even among the experts about why that is. But anyway, so the NS record is a domain name that points to a glue record, which is points to glue, which is an A record, also in the root zone. That's an IP address of your name server. So that's how we get from the root zone to the name server. That's how we get the IP address of the name server. The DS record is the hash of your public key. And the DS record, I put a lock in the root zone because the DS record in the root zone is signed by the root server. It is an authoritative record. The DS record is owned by the parent. It's a hash of the child of your key, but the DS record is the real delegation. The NS record, like I said, is hearsay, Shruggy Man, but the DS record is signed by the root. That's real. That's authoritative. The recursive resolver trusts that. Okay, we'll say that. So in the root zone, we're going to put an NS record with glue and a DS record. In the name server, so now we're leaving the root zone. We got a server on DigitalOcean now. We're going to run something like bind or power DNS. And this is where we put our zone file. And in the zone, we also put an NS record and an A record pointing back to our own name server. And like I said, it's self-referential. It's kind of weird. But basically, you don't want the parent domain telling people where to go. But also at the same time, it's like, well, if they already found me, then how is telling them where to go to find me useful? It's just the way it is. So the NS record is authoritative, hence the lock icon. It's signed by your DNS key in your zone. Let's get past that part because it's confusing. The next A record is of your web server. That's the thing that we want. When we talk about DNS connecting domain names to IP addresses, that A record right there, second one, middle of the screen, that's the A record that does that. Then finally, there's the TLSA record. The TLSA record is the hash of your TLS certificate, which will be served by your web server. So when you get an SSL certificate from Let's Encrypt using certbot, basically what you do is you take the hash of that and put it in DNS and serve it by your zone. So all these records, NSAA, TLSA, they're all signed. That's what the lock icon means. What are they signed by? They're signed by your private key. And you obviously keep that safe. The public key of that key pair is stored in a DNS key record, and that goes in your zone. And that's why I put the key icon there. It is also signed. I could have also added the lock icon there too. It signs itself. This is also a simple chart. It's also very common for there to be two DNS keys. The root zone DS record would point to a key signing key that would then point to and sign a zone signing key, and the zone signing key signs everything in the zone. I don't bother with that anymore. I use one key. You can sign your zone with a key signing key. So if you're learning if you're learning from all my mistakes, the first one is that the NS record and the root zone doesn't matter. The second one is that you actually don't need a zone signing key. You can just go right for the key signing key. If you have different security needs, obviously you can split it up with two keys, but it's a lot simpler this way. All right, so I think I covered everything on this. I don't see any Q&A, so I'm going to keep going through the slides. But this is the idea: root zone to the name server to the web server. DS record points to the DNS key. DNS key signs everything, including the TLSA record, which verifies the TLS certificate. So we need to get all these records out there and all in place. They all need to be connected the right way on these three different places: root zone, name server, web server. Let's go through it step by step. So we'll start on the right side, on the web server. This is the part that you as a web designer are probably more familiar with. So let's say you have your content ready to go on your Handshake name. What the white content on the screen here is the actual command. This is an amazing one-line command composed by my colleague Buffer. I formatted it slightly differently, and I put this exact function in my bash profile on my server, so that I've basically created a command in my terminal that's self-signed cert. Whenever I type that, this whole command is executed. Let's pick it apart so you can kind of see what's happening. It's calling OpenSSL's X509. That's the SSL certificate module. We're going to create a new 4096-bit RSA key that expires in 365 days. So, by the way, you will need to do this every year at least. The output file is called cert.key and cert.cert, and then the extension stuff. So this is where it gets interesting, because an SSL certificate needs to have the right kind of metadata. Otherwise, your browser is just going to barf. It's not going to like it. And this is where Buffer's expertise is just totally invaluable, because this is perfect. He's got everything set up right here. Basic constraints is CA false. Critical subject alt name has your domain name and your IP address in it. All this kind of stuff. So when you execute this command, it will generate a private key and then compute the public key and generate a SSL certificate and sign it itself. You don't need Let's Encrypt at all. You don't need certificate authority at all. So this is how it looks on my server, because I have that one-liner in my profile as a function. I just type self-signed cert cool domain and the IP address of whatever server I'm on. OpenSSL does its thing, generates an RSA private key, and spits the output to cert.key. Okay, and this is if you were to use the OpenSSL X509 module to look at the cert, this is what you'd see. I kind of cut the output a little bit to try to cram it all into one slide, but I just want you to notice that, especially towards the bottom there, the domain name is there, cool-domain, wildcard star.cool -domain is there, and also the raw IP address, meaning that if somebody just types in that IP address into their browser, this certificate would be valid for that connection too, without a host name. Okay. So now the next step is we need to create a TLSA record. Now we are creating a DNS record. The TLSA record, it just contains a hash of part of the certificate. Again, my colleague Buffer composed this awesome one-line command, which I turned into a function called TLSA create in my bash profile script. So on my server, I just type this command and it happens. What we're going to do is take the OpenSSL X509 module again, grab the certificate file, take the public key out of it, hash it with SHA-256, take the binary output of that, convert it into hex, make it uppercase. I mean, just Buffer's just brilliant. Like, this is just a beautiful one-liner here. So the certificate that I generated back here a couple steps ago, I typed TLSA create in that same directory, and bam, there's a TLSA record. You're looking at it, 311 B4D0F, blah, blah, blah. That's the hash of the public key. This will need to go on your name server and be signed by DNSSEC. And that's how we get from DNS to SSL to TLS, from the DNS land, from the DNSSEC land to the certificate authority land. This TLSA is that connection. And then the last step, on your web server, if this is an example of how I would set it up in Nginx, which is just my web server of choice lately. You put your, this is the config file, the sites enabled default file, or whatever you want to do. And you just put the certificate and the key that you just generated a few steps ago, you give that to Nginx so that it can do TLS and serve your website over HTTPS using the certificate that you just generated. Nginx doesn't care if it's a handshake name. It doesn't care if it's a self-signed certificate or not. You give it a domain name, an IP address, a certificate, you turn it on, it works. Okay. Now to the name server. So these commands, we're going to start with DNSSEC keygen here. These commands are available when you install bind 9. That's just the toolkit that I use. There's plenty of other options out there, and there's lots of great guides on Handypedia. There's an article there about how to set up HTTPS websites, and a lot of the stuff you'll see again there if you go check out those articles. So now we need to generate another a cryptographic key pair. This is a DNSSEC private key and public key pair. And then we will take the hash of the public key to create the DS record that'll go in the root zone. So this command, DNSSEC-keygen -a means algorithm. I use the ed25519 algorithm. It makes very small keys. It's an elliptic curve type algorithm. It's cool. And then FKSK. So here I am making a key signing key. As I said before, like you could create a key signing key and a zone signing key. You don't have to. It's more complicated. Maybe you need to do that because of the value of your domain or something. I generally don't for my little websites like the Handshake Tarot and Proof of Concept. I'll just kind of do it like this. So create a key signing key, and then cool-domain is the last argument. And then bam, DNSSEC keygen generates a key pair. It gives you the title of the key, which is kind of deterministic. And then if you output that key, you'll see this data here and cat, with the cat command. And then at the bottom of that, you see the DNS key record with some gobbledygook, which is your public key. It's nice. ed25519 keys are very short. If this was an RSA key, it'd be like blah, but it's nice and short. This DNS key will go into your zone. This needs to be served by your name server. It's a public key. It needs to be available. Then the last step is this other command, DNSSEC-ds from key, and then you put the file name for the public key, and it will hash the key and create the DS record. This is the DNS record that goes into the root zone, into the parent domain. It's the hash of your public key. It points to your public key, and that's how we create the link from the proof of work blockchain to your DNSSEC keys to the web server keys. It's actually kind of funny. It's sort of like in the characters here, like the string, actually the hash is longer than the actual key is. That's amusing to me. Okay, so we got our keys. For the name server, now it's time to write the rest of the zone. So this is what a zone file looks like before it's signed. It's got some templating stuff like this $sign kind of thing and the @ symbol. This is going to make sense once we sign it. But so I've got the origin is the TLD, cool domain, TTL 5 minutes, sure. The NS record is there. Remember what I said about how the NS record has to be inside your zone, even though that's self-referential and kind of doesn't make any sense. There it is right there. The NS record for cool domain is cool domain. You actually don't need to make ns1.cooldomain. ns1.tld is super common. Everybody's doing that. That's another kind of thing you don't have to do. SOA is a DNS thing that proves that you're in charge of the zone. Then the A record, obviously very important, the IP address of your website. In this case, I'm using the same IP address for the name server and the web server. I'm not going to elaborate on that. I think, I drew all those arrows a couple slides ago. And then finally, there's the TLSA record that we generated. And then the last line here is the $include and the name of the key file. This is a sort of a macro. When we do the sign command in the next slide, the signing software will see that $include and know what it needs to do. instead of explaining, I'm just going to show you. So we'll get there. So this is the command. So we started with this. This is our zone file sort of template, the unsigned zone. We do not serve this file. It's just input to the next step. This is the next step. DNSSEC-sign zone. -Z, I think, is what you need to add if you're going to use a key signing key only. Instead of having two separate keys, you need to put that -Z there. -O, cool domain, is the output or the origin, sorry, of the domain, and then cool-domain.zone is the name of the file that we created here in this slide. And then this is the output, verifying the zone using the following algorithms at 25519, zone fully signed, alerts the algorithms. Note how the output says 1 active KSK, key signing key, 0 active zone signing keys. That's okay. It's actually okay. You don't need a zone signing key. And this is what the zone looks like once it's signed. It's huge, right? We started with this like short little template, signed it, and now all the stuff is in here. You'll notice there are RR SIGs. These are the actual cryptographic signatures over each record type. This is the signed zone file. This goes to your name server. There's no private keys here. The nice thing about DNS is you can always sign it offline and then just put the signed records on your hot server, and nothing can really happen bad to it there because your private keys are safe. And you can take a look at this, like the SOA record is there, it's signed. The DNSSEC key, the DNS keys are here on the top right. Remember, I had that $include macro that got turned into the DNS key record. The sign zone function pulled that key from the file and put it into my sign zone and signed it. So we're all good. You can see the TLSA record is there. It's important to have a wild card for the TLSA record, that star, because when Dane actually comes along, it's not going to just look for cool domain TLSA. It's going to look for _443._TCP. Cool domain. So try to remember that back here I have the star by the TLSA record, and that's going to be important. So now we're ready to configure the name server. We've got the content for the name server, which is our signed zone. This is 2 example configuration files for named, which is by bind, and NSD, 2 different name server applications. You can kind of see the resemblance in the configuration file. Basically, you just tell the name server the name of the zone it's serving and where the file, the signed zone file, is on your drive. That's it. And then finally, we get to the root zone, everybody's favorite part. This is where Handshake finally comes in. You could do this with Namebase. You can do this with HSD. You can do this with Bob Wallet. You take the DS record that we generated a couple slides ago, and you got to put that on chain. In Handshake, with HSD, we use this send update command with the domain name, and then you put the DS record, and I'll explain a synth record in a second. Actually, I'll explain it right now. So there's a couple ways to get that NS record with its glue in the Handshake root zone. If your Namebase, you could add an NS record and a glue record, which is redundant and wastes blockchain space, but you can do that if you really want to. An NS record just has a domain name. A glue 4 record is a special type of Handshake record that includes a domain name and the IP address, which is what makes that NS record redundant. So you don't have to do that. You can just use a glue 4 record, and you can have ns1.cooldomain and then the IP address. The coolest way to do this, which is still maybe a little has some pitfalls, which I'm not going to have time to explain, but all of the websites that I run on Handshake use synth 4 records. These are cool because they require the least amount of blockchain space, and that might not be a concern to you now, but hopefully blocks start getting really full on Handshake, fees go up because people are really using it. So keep this in mind in the future when fees matter and you need your root zone records to be small. What a synth 4 record does is all you give it is your 4-byte IP address, 123.201.32.45, 4 bytes, with no domain name, no NS record, just the IP address. And then what happens is that HSD, the root server, will translate that into a set of NS records plus glue in a very brilliant way, which I don't know if JJ invented this or if there was already some kind of DNS precedent for using base 32 and domain names. But either way, it's super cool. And here's what the output looks like at the bottom of the slide. So if I was going to ask my Handshake root zone server for the cool domain root zone records, it would look like this. it would provide this NS record, which is magic. It came out of nowhere. You might say it was synthesized. And it's got this gobbledygook _FF4I0B8. And that is my IP address encoded in base 32. Because that's the only data that you actually need to give the root zone. There's that IP address. It was turned in, synthesized into this NS record for a name that doesn't exist and is totally invalid, actually. And then in the glue section, that synth record is matched with your actual IP address. So the name server that I use is a Handshake domain name that I got off Namebase for like 1HNS. It's the name Omnitude. And if you go ahead and look at the root zone records, you'll see a synth record there. And this is what's happening. And then all my other sites, like even Impervious and the names don't resolve in what we call the internet and the Handshake Tarot, they all use Omnitude as their name server. So if you're having problems resolving any of the websites that I share, it's probably because your Handshake resolver is not handling synth records. And actually, there were some bug fixes involved in synth records maybe a year ago. So if you're having problems visiting my sites, you got to update your software. Anyway, synth records are cool. I've only got 5 minutes left, but I think I've basically done it. Okay, so here we go. Cool domain. This is what it looks like. I actually did this. This isn't photoshopped or anything. I created cool domain in regtest on my computer and set this up with Let's Dane. You can see the lock icon there. We did it. We're done. So in the last couple of minutes, I'll tell you sort of a cheat code to this whole process is something that I wrote a couple of years ago called Handout. You can find it on a Handshake domain, handout.js, which will redirect you to GitHub, which is an ICANN domain, but that's okay. It's an easy way to find it, handout.js. And what I do is let's go back to here where there's 3 bubbles. I combine the name server and the web server into one single JavaScript process using tools written by JJ, using BNS and BWeb. And there's one single command. It's hnsec-gen. And you just execute it along with your domain name and your IP address. And let's see what happens. First, the script will generate a self-signed certificate. Then it generates DNSSEC key pair, and it writes configuration file, and it gives you the DS record, and it gives you the records to either type into Namebase or to paste into Bob Wallet or to broadcast with a transaction using HSD, and you're done. This is my last slide. So if you just want to get a simple single page static website on Handshake with Dane, Handout is a really easy way to do it. And I think a lot of users have done it. Then people start asking, well, what if I want to use IPv6, or what if I want multiple websites, or what if I want to do extra stuff? That's when it's time to come back here and do the cool stuff and do it the right way. But if you've never had a HTTPS secured website on Handshake before, I recommend starting with Handout, and it's a good way to learn. Okay, so that's Dane. I'm looking forward to seeing a lot of great secure website submissions in the website race, and Fistful will have all kinds of more details about that. I'm not seeing any questions. I've got a couple minutes left. If anybody wants to ask anything.
I just wanted to add really quick too. Make sure if you are interested in building a website, make sure you come and join the Website Race Discord. It has all the information you need, all about the requirements to submit a website, and all the prize information. You can win. First place gets 2K HNS. Second place gets 1K HNS. And even if you don't win in in first or second place, we're giving 500 HNS to 25 websites, across all the categories. So even if you don't win, you win. So yeah, just join, build, and get some free money, man.
Build just content. You don't have to invent something. Just make a website on Handshake with a bunch of poems you wrote, or a drawing of your cat, or like if you're a really good web developer, put a video game or an application or a forum where people talk about like organizing labor or democratic revolution or something like that. Anything along that spectrum. Just put up websites on Handshake. So I got something to type into the Beacon browser.
That's we want to surf the DWeb. That's what we want to do.
That's it. We're talking about DWeb. There's nothing out there. So let's put some websites up.
Yeah, for sure. All right. So I'm gonna cut it here and give us some transition time into our next talk, where Luke is gonna talk about HIP5 in hyperzones, which is gonna be really interesting. I hope you guys show up for that one. Yeah. All right. See you guys in the next one.
Thank you. Bye.
Kinetic is a blockchain crypto investment firm based in Hong Kong and Puerto Rico. Founded in 2016, they were the first fund in Hong Kong and one of the earliest in Asia. With a portfolio of over 220 companies, they were seed investors in such projects as Ethereum, Parity and Polkadot, Solana, FTX and of course Handshake and Namebase. Founder Johan Chu is an active investor and supporter of the Handshake ecosystem. Over 100,000 domains, co-founder of DWeb Foundation, co-founder of HandyCon, and sponsor of the Handshake House at Miami Hack Week 2022.